All right, welcome to Mid-Mission Study Guide for Mission 4. I'm going to start on the front page with number 1. And number 1 says to us, without computing. What does that mean? Computing. That means without actually doing the math. So we're more estimating, okay? Decide whether the value of each expression, these are expressions because they do not have an equal symbol after them. If they had an equal symbol right here, it would cease, which means stop, to be a expression, and it would then be an equation. But because these do not have an equal symbol at the end, they are expressions. All right, so decide whether the value of each expression is much smaller than 1, close to 1, or much larger at 1 than 1. Explain your reasoning. That means that you are expected to use words to tell us why you have chosen that answer. Okay? So explain your reasoning. All right, first question, or first expression that we are going to decide is smaller than 1, close to 1, or much larger than 1. Explain your reasoning. All right, so we have 18.5 divided by 17 3/4. Okay, first thing that we need to do is look at the relationship of the dividend and the divisor. When the dividend and the divisor are very close to being the same number, right, when their values are not very far apart from each other, 18.5, 17 3/4, even if we didn't look at the numbers, the fractions that come after, we could very reasonably decide 18 and 17 are two numbers that are very close to each other. Well, when you divide numbers that are the same, you always get 1, right? So if I divided 9 divided by 9, 1. 100 divided by 100, 1. 1 divided by 1, 1. Any number divided by itself equals 1. Well, why? Because this is how many you have, and this is the size of each group. So if I have 100 things and I have to make a group, and there's 100 things in that group, it only makes one group. So easy peasy. Any number divided by itself equals 1. So if numbers are close to each other, then it's reasonable to assume that that answer is going to be close to 1. Okay, so look at the relationship between your dividend and your divisor, and if those numbers are close in value, then your answer is going to be close to 1. Now let's give our reasoning, though. We're not done yet. So to explain the reasoning, we could say the dividend and the divisor. We should be becoming very comfortable with these words. These are your vocabulary words that are on your warm-up every morning. So the dividend and the divisor are, close to equal. Right? They're close to being the same number. So you will only be able to make one full group. Even if you've got a little fraction more, you're still only going to be able to make one full group if those dividend and divisor are close to equal. If they are equal, then your answer is exactly 1. If they're close to equal, your answer is going to be close to 1. All right, let's look at B. We have 11 4/5, so that's almost 12 because I've got 4 out of the 5 parts. That's almost like having another whole. So we've got a number that's close to 12 divided by 2/5. Well, that's not even one whole. So this is a really small number, right? This is a value that is very small. 2/5. It's not even half. It's less than half. So we've got a number that's almost 12 whole, and we've got a number that's not even half of a whole. Well, when we have a dividend that is much greater than the divisor, so these are all the things that we have, and we barely have to put anything into each group, we're going to end up with having a quotient, an answer, right, that is much larger than 1. You're going to be able to make so many groups. If I had 100 jelly beans, and I only had to put 2 jelly beans in each pile, so if I had 100 divided by 2, I would be able to make so many piles of jelly beans. Or I would say there are so many jelly beans in each pile. So now we have to explain our reasoning. The dividend of 11 4/5 is much greater than the divisor. So you can make many groups of 2/5. All right, period. All right, C. We have 3,900,000 divided by 0.3. Man, 0.3, that's like 1/3. So we have 3,900,000 divided by way less than a whole, right? 1/3. That is a really big dividend to a really small divisor. And what did we just say about when your dividend is much greater than your divisor? You can make so many groups, or put so many in each group, whichever way the divisor relates to the dividend. So we can make much larger than 1. Our quotient would be much larger than 1. And just like our reasoning for B, the dividend is much greater than the divisor, so you can make many groups of 0.3. All right, last one. I'll move this up for you so you can see it better. There we go. All right, so last one. We have 2/5 being divided by 7 3/10. 2/5, so that's less than a half again. 2/5, less than a half of a whole, being divided by 7 wholes and 3/10. You won't even be able to make one whole group, right? You'd be making way less than one group. Because if I only have 2/5, if I have 2/5 of a pie, so 2 slices out of 5 slices, and I have to split that up among 7 people, if 7 people are going to share 2 slices out of 5 slices, they are going to get way less than a whole slice. So our answer is going to be much smaller than 1. It's either going to be a fraction with a very low value, or it's going to be a decimal with a very low value. Much smaller than 1. And to explain that, the dividend is much smaller than the divisor. right? The dividend is much smaller than the divisor, and any time that the dividend is much smaller than the divisor, there will only be part of a group, so less than a whole, not even one whole, so much smaller than one whole. Anytime that the divisor is much greater than the dividend, anytime the dividend is much smaller than the divisor, there will only be part of a group of, oops, not 2/5, of 7 3/10. Okay? So this is how many groups we have to make, or how big each group needs to be, because your divisor always represents the number of groups or the size of each group. And I'm not going to be able to make a group of 7 wholes and 3/10 if I only have 2/5 to begin with. I'll only be able to make part of that group, and it'll be much smaller than one group. All right, that is your first page. All of that was part of number 1. But you'll be graded on each A, B, C, and D individually, and you are not only being graded on whether or not you can choose the correct of the 3 possibilities, you are being graded greatly on your reasoning. So on your final assessment on Friday, tomorrow, make sure that you really think about that explanation or that reasoning, because if you skip that, you will not get a passing grade on number 1. All right, number 2. All right, number 2 says, Sally made a large pot of spaghetti sauce, and she plans to divide the sauce equally into smaller containers. Well, this happens to me all the time. I make a big dinner, and then after we eat, there's leftovers, and I divide it into smaller containers so Mr. Himmel can take it with him to school for lunch. So, if I had a large pot of spaghetti, and I wanted to divide it equally into smaller containers, this is what I would do. If a pot contains 26 3/4, so 26 whole cups and 3/4 of a cup of sauce, describe 2 different ways to interpret. What does interpret mean? Make sense of, explain, right? To interpret, how are you going to make sense of the expression 26 3/4 divided by 4? All we know is that we're putting it into smaller containers. It does not say how many containers there are. It does not say how many cups of the sauce she wants to put into each container. So this 4 could either be telling us to divide 26 3/4 cups of spaghetti sauce into 4 containers, or it could be saying take 26 3/4 cups of spaghetti sauce and put 4 cups in each container. So this would tell us how many groups we're going to have, and your answer would be how many cups of sauce are going into each group or container. Or this could be the size of each group, so we don't know how many containers we were going to fill. That would be what we're finding out. Okay? So it says to explain 2 different ways, or describe 2 different ways to make sense of this. So I could say one way to interpret this information, I could say 26 divided by 4 could represent, represent how many cups of sauce will Sally put in each container? if she uses 4 containers, or this could mean, it could be interpreted as 26 3/4 divided by 4 could be interpreted, I missed some letters there, interpreted as Sally saying, how many containers will Sally need or fill, right? How many will she need or how many will she fill if she puts 4 cups of sauce in each container? Because we know what the 26 3/4 represents. What we don't know is, what does the 4 represent? Does it represent 4 containers and an unknown amount in each container? Or does it mean that she is going to put 4 cups in each container, and what we don't know is how many containers that will fill? So 26 divided by 4 could represent how many cups of sauce will Sally put in each container if she uses 4 containers, or 26 3/4 divided by 4 could be interpreted as how many containers will Sally need or fill if she puts 4 cups of sauce in each container. All right, that is number 2. All right, number 3. How many 3/4? Okay, so if 3/4 was a thing, right? How many 3/4 are in 4? Use a tape diagram to support your answer. So what that means is, the way that we use a tape diagram to support our answer is we can label this as we go, okay? So we're going to use the tape diagram to support our answer by showing, what does this tape diagram show us? How is our answer in this tape diagram? They've already drawn the tape diagram, they've already split the tape diagram, they've already shaded. Your answer is right here. We just need to make sure we understand what is here in order to answer the question. So we know that this whole bar represents 4. And I can see that right here. Oops. These solid lines. Remember how we say that we use the solid lines to break apart our wholes, and we use these dotted lines to represent the parts of the whole. So I see that I have a whole here, right? This is 1. This is 1. This is 1. This is 1. Okay, I can see all of the 4 holes there. Now I also see that each of these holes here is being divided into 1, 2, 3, 4 parts, right? We've got a part here, we've got a part here, we've got a part here, and we've got a part here. When we have a whole divided into 4 equal parts, each one of those parts is a 4th. Okay, and this pattern continues with all 4 of them. All 4 of my holes are divided into 4ths. So every little section of this diagram is 1/4. Now, I also have some shading going on here. I've also got 3 of these 4ths grouped together. Well, when you have 3 4ths grouped together, that's 3/4, right? So each one of those is a 4th, and this whole group is 3/4. Okay? So and our question said, how many 3/4 are in 4? So every one of these groups here So I've got one here. I've got one here. I'm going to mark them with an X so I see them. Maybe if I can get this pen to work. So I've got 3/4 here. 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 And then I have this piece. All right, well, first thing, let me just go ahead and figure out how many 3/4 I have. I've got 1, 2, 3, 4, 5 3/4. So I'm going to go ahead and write that down. I know I've got 5 whole 3/4, and this one shows it in an equation form. 4 divided by 3/4 equals 5, and I'm going to have a fraction, but I'm going to make sure I write down this 5 because I don't want to forget that. There are 5 groups of 3/4 and 4, and a fraction. So I've got this part of a group of 3/4. This is no longer a fourth the way that we are now thinking about this. Okay, we're wondering, how does this piece here relate to one of our groups is 3/4? Okay, so what we're going to say is this piece right here, how does that relate to this thing here that we're calling 3/4? We could say this is a cake. It's 3/4, it's a cake, it's a piece of paper, whatever. How does this piece relate to here? Well, if I was able to pick this up and set it on there, I would see that this perfectly covers up one out of these 3 sections. So when you have one part out of 3, that makes the fraction 1/3. So I have 5 3/4 and a third of a 3/4. So your answer is 5 3/4. All right, number 4. This says, how many 2/5 are in 5? Use the tape diagram to support your answer. Okay, we're doing the same thing again. We have the tape diagram drawn for us, but the thing they have not done for us yet is done all the shading. On the last one, it was so easy to see all of our different groups. Now they have shaded one group, haven't they? So let's go ahead and take a look. We see that there are going to be 5 holes. Let's make sure that we can identify those 5 holes. So this is a split between each of those 5 holes. I just want to make sure that we can see one hole, one hole, one hole, one hole, and one hole makes 5 holes. This whole bar represents 5, and there they are. Now the other thing that it's done is split each of those holes. We need to see how many parts. 1, 2, 3, 4, 5. Oh, that's good because we're dealing with fifths, so I'm glad that it's already broken into fifths for us. So every one of these small sections is a fourth. Nope, not a fourth, sorry. Every one of these small sections is a fifth. Our last one was fourths. Every one of these is a fifth. So there are 1, 2, 3, 4, 5 fifths to each hole. But it told me, my problem, told me to figure out how many 2/5 there are. That's why these first 2 boxes here are shaded in for me. This is a group of 2/5. So every 2 of these small sections, every 2 of these fifths makes a 2/5. So that means I've got one there, one there. Oh, can we count both of these? They're not part of the same hole. Yes. That's still 1 2/5. It doesn't matter that they're part of 2 different holes. Another, and another, and another, and another. These 2 straddle this hole, but it's okay. Oh, and I've got that. Let's go ahead and figure out how many holes I have. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, that's so many. So I have 12 2/5 in my 5 holes. I have 12 2/5 and this piece. So this is no longer, we're no longer going to look at this as a fifth. We're going to look at this as part of a 2/5. Okay? We're going to look at this as part of a 2/5. We're going to think of this as a cake, right? How does this piece relate to this? Well, this is 1 out of 2 pieces. This is the size of one of these pieces out of 2 pieces. So if you have 1 out of 2, your numerator is the 1, your denominator is the 2, and what fraction is that? We all know that. So we have 12.5 groups of 2/5 in 5. All right, number 5. This one's got multiple parts to it, so we want to make sure that we do all of the parts so that we get all of the points. All right, Julie made 4 quarts of iced tea and she plans to sell it by the glass. If each glass holds 2/3 quart, how many glasses of iced tea can she sell? So my goal is to be able to tell how many glasses of iced tea can Julie sell. Well, part A of this problem is to use the tape diagram below to determine how many groups of 2/3 are in 4. So are in 4. That means 4 is my total, okay? This whole bar is going to represent 4 quarts. So I'm going to go ahead and split this up to show those 4 quarts. So every one of these is 4 quarts. Now the next thing that I need to do is I need to break this into 2/3, groups of 2/3. So I want to know how many 2/3, because each cup is going to hold 2/3 of a quart. So I need to break each of these holes into thirds. Try to get them as even as possible. It's not the best, but all right. So every one of these smaller sections is a third, all the way across. Okay, I've got all of those thirds. Now I have to see how many groups of 2/3 there are. So I'm going to be putting 1 2/3 together to make a group of 2/3, right? So this is one group of 2/3. Then I'm going to go ahead and make another group of 2/3. So here's another 1 2/3, right? So we've got another group of 2/3. And I'm just going to keep doing this until I have found all of the groups of 2/3. Every 2/3 that are next to each other become a group. And during the test, if you would like to use colored pencils, you are more than welcome to. Alright, so I've got 2/3, 2/3, 2/3, 2/3. So being a group of 2/3 also counts as being a cup of iced tea, because each cup is going to hold, right? Each glass holds 2/3 of a quart. So I just made 1 cup, 2 cups, 3 cups, 4 cups, 5 cups, 6 cups. Not cups like the measurement, glasses, sorry. 6 glasses of iced tea that are each 2/3 quarts out of a total of 4 quarts. So to answer A, we needed to use the tape diagram, because it says it right here. Use the tape diagram. We just did. We labeled it. It's beautiful. Now we're going to use that to answer this question. There are 1, 2, 3, 4, 5, 6. 6 groups of 2/3 in 4. You write a division equation to represent. Well, I took 4 wholes and I divided it into groups of 2/3, which made 6 groups. Okay, that's what the division equation would be to represent this problem. And what does your quotient? We have used this word in class before, and this is a vocabulary word that you should have learned in the 4th grade. The quotient is the answer to a division problem. So when they say quotient, what are they talking about? They're talking about this 6. So what does the quotient in part B, this is part B, so quotient, part B, here it is, represent in the context of this situation? So they mean when thinking about this situation, what situation? The situation that Julie has, right? When they say this problem, they're talking about this. So how does the quotient from part B represent the context, or have to do with, how is it related to the problem here? Well, the problem was how many glasses of iced tea can she sell? So that quotient of 6 represents, so we're going to explain the quotient means, right, so what does the represent in the context? It means that Julie, from way up here, right, Julie is the person in the problem, can sell 6 glasses of iced tea. Okay, so we took 4 whole quarts, we divided it into groups of 2/3 because each group of 2/3 equals 1 glass of iced tea. So here's 1 glass here. And I did that 6 times. 6 times I was able to make a group of 2/3. So that means that the quotient of 6 means that Julie can sell 6 glasses of iced tea. Alright, number 6. Alright, last 2 problems. Number 6 here. Alright, all we are given is a tape diagram and an equation. 1/4 divided by 4 equals. So 1/4, this is what I have, divided by 4. How many groups of 4, here's a group of 4, how many of these, the whole thing, are you able to make when you have 1/4? Oh, that's so much less than 1, isn't it? Because 1/4 is way smaller. This dividend is way smaller than your divisor. So you're only able to make way less than a whole group. And to be precise, to be exact, it is 1 out of 16 parts because it said fourths. So that means that every one of my wholes gets broken up into fourths. So every one of these is a fourth, right? And all together in 4 wholes, there are 4, 8, 12, 16 fourths. There are 16 total fourths, and I have 1 out of those 16 fourths. So that means that when you take 14 and try to make a group of 4, you are only able to make 1/16 of a group. It takes 16 fourths, and we can see that right here. It takes 16 fourths to make 4 wholes. So 1/4 is 1/16 of 4. All right, last one, guys. Last one, number 7. After walking for 2/3 of an hour, Kelly is 1/4 of the way through the hike. How long will it take Kelly to finish her hike if she continues at the same pace? Use the tape diagram to solve. All right, they've not done anything for us on this tape diagram. We have to determine what the whole tape represents. We have to determine how many parts to break it into, or how many holes to break it into, how many parts each hole needs to be. We need to figure all of that out. So let's go back and read our problem again, because I really have to interpret the information. After walking for 2/3 of an hour, okay, so out of a whole hour, 60 minutes, right? Whole hour, there's no name, right? Oh, Kelly. Kelly is only 2/3 of the way through, okay? All right. Kelly is 1/4 of the way through her hike. So she's only 1/4 of the way through her hike, the whole hike. She's only 1/4 of the way through the whole hike. How long will it take Kelly to finish her hike if she continues at the same pace? Okay, here's what we need to think of. What's our hole? Well, what is it that we're breaking up, or what is it that we're trying to finish if we're not breaking it up, if we have less than the entire thing? The hike. The hike is our hole. We're trying to figure out how long it will take her to finish her hike. That's her hole. So your tape diagram represents the whole hike. All right. Now, she's only finished 1/4 of the way. So I need to show how much of this hike she's done so far. So if I have to shade in 1/4 of this hole, I better break it into 4 parts. Can't shade 1/4 of it if I don't have 1 out of 4 parts to shade. So this is 1/4 of Kelly's hike. 1/4 of the hike. Okay? Now, I know that Kelly took 2/3 of an hour in order to hike this, it took 2/3 of an hour for Kelly to travel 1/4 of the hike. So 2/3 is equal to 1/4 of the hike. Well, this is 1/4, and I have to show 2/3, so that means I need to break this quarter into half in order for that to represent 2/3 of an hour. Now, I'm going to keep doing that because I have to keep everything equal. Now, every one of these boxes represents a third. Here's 2 of them boxed together. Now, let's use this to figure out how many or how long it took her to travel the whole hike. Well, here's 2/3 of an hour. Can I make a whole hour? Well, 2/3 needs another third in order to be a whole. Choose a different color. Where'd my blue highlighter go? Lost it. Here we go. Well, here's 3/3, so that's a whole hour. Here's 3/3, that's a whole hour, and I have 2 more thirds. So I have 1 whole hour, 2 whole hours, and 2/3 of an hour. So Kelly will be able to hike the entire hike in 2/3 of an hour. Now I'm going to write a multiplication sentence that represents the time for Kelly's hike. Okay, well, what did we do? We took 2/3 and we showed that 2/3 1, 2, 3, 4 times, right? Because those were fourths, times 4 to find our unknown, which we know is 2 and 2/3. Then write a division, so I'm going to find the inverse of my multiplication. So I know I take this and move it to the beginning, 2 2/3, divided by, right, and that was also my unknown before I solved it. 2 2/3 divided by into those groups of 2/3 equals 4. So Kelly hiked for 2 2/3 hours. All right. I hope that you have done everything on your study guide that I have done on mine. And I hope that you use this to study tonight, and I hope that you choose to finish all of your Zurn lessons to prepare for this assessment, or not all of them for the entire mission, but all of them for the mid-mission, so the first 9 lessons. All right.